Now what is this A cross B? A cross B is called as the Cartesian product of the two sets. If every element of set A has one and only one image in set B, then it is denoted as f from A to B is a function. The element 2 of the set A has two images 2 and 4, therefore this is not a function. Hello dear students, welcome to this session of Discrete Mathematics class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Today in this session I am going to discuss regarding now ordered pairs, and by knowing the ordered pair we are going to write the Cartesian form and the definition and example for functions. Now let us come to the first one, ordered pair. Now that is Cartesian product of sets. In that Cartesian product of sets, let us discuss regarding the ordered pair of a set. Ordered pair means, let us recall from our earlier classes that ordered pair of an element taken from any two sets P and Q is a pair of elements written in a small bracket, that is the parenthesis, and grouped together in a particular order like P comma Q, where P belongs to P and Q belongs to Q. That means, let me explain. Suppose let us consider two elements. If A and B are any two elements, if these two are enclosed between the parenthesis A comma B, then this is called an ordered pair. This is called an ordered pair. They are called as an ordered pair. That means here, first member is an element of first set and second member is an element of second set. Suppose if P and Q are any two elements of the set, P is an element of the set P and Q is an element of the set capital Q, then P comma Q is nothing but an ordered pair where P belongs to P and Q belongs to Q. So that means in general, if A and B are any two elements of the set, then A comma B, the parenthesis A comma B enclosed between the small brackets is called an ordered pair of a set. By knowing this ordered pair, let me take one example. Suppose if A is equal to 1 comma 2 and B is equal to 3 comma 4, then let me write the Cartesian product for this. The Cartesian product of two sets is denoted as A comma B. A cross B. A cross B is called the Cartesian product, and in which A cross B is nothing but the set of all ordered pairs. So let me take 1 comma 3 and 1 comma 4. Similarly, next element 2 comma 3 and 2 comma 4. So this is called an ordered pair. So the set of all ordered pairs. So these are all called as ordered pairs. Now what is this A cross B? A cross B is called as the Cartesian product of the two sets. Now let me define the Cartesian product. Now given two non-empty sets P and Q, the Cartesian product of P and Q is denoted as P cross Q is the set of all ordered pairs of the elements from P and Q, that is P cross Q is equal to a set P comma Q such that P belongs to P and Q belongs to Q. That means first member is an element of set P, and second member is an element of set Q. So let us consider, for example, if A is equal to 1, 2, 3, another set B is equal to A, B, C. Now let me write the ordered pair. Ordered pair A cross B, denoted as A cross B is equal to the set of all the elements. Ordered pair, the Cartesian product of A and B is denoted as A cross B is a set of all ordered pairs in which first member is an element of set A and second member is an element of set B. Let us see how I am going to write. Now let us take this first element 1 comma A, then 1 comma B and 1 comma C. Now let us consider the second element 2 comma A, then 2 comma B, 2 comma C. Next third 3 comma A, 3 comma B and 3 comma C. So this set of all ordered pairs is nothing but the Cartesian product of two sets A and B, that is denoted as A cross B. The set of all ordered pairs comes under the Cartesian product. So that means how to define? Given two non-empty sets P and Q, the Cartesian product of these two sets P and Q is denoted as P cross Q is a set of all ordered pairs the set of all ordered pairs of elements from P to Q, that is given by P cross Q is equal to P comma Q, such that P belongs to P and Q belongs to Q. This is an example for the Cartesian product of two sets. Okay. Now let us take one more example. If A is equal to x comma y, another set B is equal to A comma C, then the Cartesian product from A to B is denoted as A cross B is equal to set of all ordered pairs. So here x comma A and x comma C. Similarly, let us take the second element y comma A and y comma C. So this is called the Cartesian product. So Cartesian product in which first member is an element of set A and second member is an element of set B. So all ordered pairs comes under this set, that is A cross B, denoted as A cross B, is called the Cartesian product of two sets. Now let us take a simple problem based on this Cartesian product. Now this is an important type problem. If x plus 1 comma y minus 2 is equal to 3 comma 4, find the values of x and y. So by equality, just equate first coordinate to first point. So here x plus 1 is equal to 3 and y minus 2 is equal to 1. Now this can be written as x is equal to 3 minus 1, x is equal to 2. This can be written as transfer minus 2 to the right hand side plus 2, y is equal to 3. So therefore the ordered pair x comma y is equal to 2 comma 3. That's it. X comma y is equal to 2 comma 3. So here the value of x is 2 and y is equal to 3. Hope you follow. Just equate it. X plus 1 is equal to 3, y minus 2 is equal to 1, x is equal to 3 minus 1 is 2, y is equal to, transfer minus 2 becomes plus 2, 1 plus 2 is 3, y is equal to 3. So 2 comma 3 are the values of x and y. Now let us take similar type problem. If x by 3 plus 1 is equal to comma y minus 2 by 3 is equal to 5 by 3 and 1 by 3, find the values of x and y. Same type problem. Equate these ordered pairs. First element x by 3 plus 1 is equal to 5 by 3 and the second element y minus 2 by 3 is equal to 1 by 3. Okay. Now if you want, take LCM and simplify. Otherwise you can transfer this. X by 3 is equal to 5 by 3 plus 1 becomes minus 1. X by 3 is equal to, take LCM, 3 is the LCM, 5 minus 3 ones are 3. So x by 3 is equal to 2 by 3. Cross multiplied, 3x is equal to 6, x is equal to 6 by 3 is 2. So x is equal to 2 is the value. Similarly on the other hand, so y minus 2 by 3 is equal to 1. Transfer this, 1 by 3 minus 2 by 3 becomes plus 2 by 3. Y is equal to, 3 is the LCM, 1 plus 2, that's equal to 3 by 3 is equal to 1. Y is equal to 1. So the value of x is 2 and y is equal to 1. X is equal to 2 and y is equal to 1 are the values. If you want, you can verify. Just if you want, you can do the verification also. What are the values? X by 3 plus 1 is equal to, how much you want to get? 5 by 3. Check. X, what is x? X is equal to 2 by 3 plus 1. Take LCM, 3 is the LCM, 2 plus 3 ones are 3, that's equal to 5 by 3. So this is how we are going to find the values of x and y whenever the ordered pairs are given, right? Now let us come to the next example. Now suppose if A is equal to, this type of problems are very important. Let A is equal to 1 comma 2 comma 3 and B is equal to 3 comma 4 and C is equal to 4, 5 and 6. Find A cross B intersection C and A cross B intersection A cross C. This is what we want to find. This type of problems are very, very important type for 5 marks. Now let us come to the first one. Now find out B intersection C. B intersection C. In the previous classes we have studied intersection is nothing but the common elements in B and C. So what are the common elements? 3 is there, here is not, it is there. So 4 is in both the sets B and C. 5 and 6 in set C, but it is not in B. So B intersection C is 4. Now write down this. A cross B intersection C. A is nothing but 4. B yes, A is 1, 2, 3. This is 1, 2, 3. So the elements are 1, 4, then 2, 4 and 3, 4. These are the elements of A cross B intersection C. What is A contains? 1, 2, 3. What is B intersection C contains? Only one element. So the Cartesian product of these two sets is 1, 4, 2, 4 and 3, 4. Now on the other hand, find out first A cross B and A cross C. Let's find out A cross B first. A cross B is equal to the Cartesian product of A and B. So let us take 1, 3, 1, 4. Next 2, 3 and 2, 4. Next element is 3, 3, and 3, 4. So these are the Cartesian product of A and B. Similarly, A and C, Cartesian product of A and C. A and C, so that is between these two. 1, 4, 1, 5, then 1, 6. Similarly, 2, 4, 2, 4, 2, 5, then 2, 6, then 3, 4, then 3, 5 and 3, 6. Now the union of this, intersection of these two. Now therefore, A cross B intersection A cross C, the common in these two. So in the first set we have 1, 3. Here 1, 3 is not there. 1, 4 is common in both the sets. 1, 4 we can take 1, 4, 1, 4. Then 2, 3. Here we don't have 2, 3. Again 2, 4. 2 and 4 is there in both the sets. We can take 2, 4 here. 2, 4 and 3, 3. 3 and 3 is not there. 3, 4. So 3, 4 is in both the sets. So 3, 4. This is the required answer. So A cross B intersection A cross C is equal to 1, 4. 1, 4 is included in both the set. Then 1, 3 is not there. 2, 3. 2 and 3 is not there. 2 and 4. 2 and 4 is included in both the sets. Then 3, 3 is not there. 3, 4. So therefore, this is the expect the problems for your final examination for 5 marks. Okay. Now let us come to the next problem. Now here this, what is the problem given? If A cross B, already Cartesian product is given, A cross B is equal to P, Q, P, R, M, Q, M, R. Find A and B. So here what is required to find is the values of set A and set B. Now set A is nothing but, as you know, set A is nothing but set of all first elements of the ordered pair, and set B is nothing but set of all second elements of the ordered pair. What are the first elements? We have P, then already P is repeated, M, then that's it. P and M are the first elements. What is that is called A, and the second set B is nothing but set of all second elements of the ordered pair. Second elements are Q and R, Q and R. So if you write the Cartesian product for this, you will get the same answer, A cross B, P, Q, P, R, then M, Q and M, R. So these are the values of A and B. Okay. Now suppose if you want to write the triple product, suppose if A is equal to 1, 2, then A cross A can also be written as, now first write down A cross A first. A cross A is equal to 1, 2 cross 1, 2, the Cartesian product of these two, that is 1, 1, 1, 2. Again 2, 1 and 2, 2. Then we can write A cross A, that's equal to 1, 2 cross this 1, 1, 1, 2, 2, 1 and 2, 2. Now if you write this is equal to, what is the answer we are going to get is 1, 1, 1, 1, 1, 1, 2, again 1, 1, 2, 1, again 1, 2, 2. Similarly, take this element 2, 1, 1, again 2, 1, 2, then 2, 2, 1, and the last element 2, 2, 2. This is the value of A cross A. That's it. Okay. This is how we are going to write the Cartesian product. Now, by knowing this Cartesian product and the ordered pair, let us come to the definition of a function. Now, what is a function? Let us come to the function. Definition of a function. A relation from a set A to set B is said to be a function if every element of set has one and only one image in set B. If every element of set A has one and only one image in set B, then it is denoted as f from A to B is a function. See, a function is a relation from a non-empty set A to a non-empty set B such that the domain of f is A and no two distinct ordered pairs in f have the same first element. No two distinct ordered pairs in f will have the same first element. This is very important point. Now, if f is a function from A to B, that is A comma B belongs to f, then f of A is equal to B, function of A is equal to B, where B is called the image of f, image of the function A under f, the image of element A under f, and A is called the pre-image of B under f. So, here the element B is called the image of A under f and A is called the pre-image of the element B under f. So, therefore, the function from A to B is denoted as f from A to B. Now, let me explain by taking an example. Let us come to an example. This is an example. Let us consider two sets. This is A and B. F from A to B is a function. See here, the elements are mapped from 1 to P, 2 to Q and 3 to Q again. So, here this is the values of functions are f is equal to 1 comma P, the ordered pairs, again 2 comma Q, 2 comma Q, again 3 comma Q. Now, this is a function from A to B. Let us come to this example. Here this is A and this is B. So, f from A to B is a function. F from A to B is a function here. See the map 5 to 3, 5 comma 3, again 6 comma 4 and 7 comma 5. So, here, so 5 is related to 3 and 6 is related to 4 and 7 is related to, so there is an unique association. No element of B, A has used 2 times. So, therefore, this is 1-to-1 mapping. Now, let us come to the third example. In this example number 3, the elements of the set, yes, the function are 1 comma P, 1 is related to P. Again 2 is also related to P, 2 comma P. Again 2 is related to Q, 2 comma Q. And again 3 is related to R, 3 comma R. Now, observe carefully here. The element 2 of the set A has used 2 times. See, 2 comma P and 2 comma Q. So, therefore, this is not a unique association, hence this is not a function. So, f from A to B, this f from A to B is not a function. This is not a function. This is not a function. These two are the functions, example for functions. So, no element of the set A should be used 2 times. So, here 2 has 2 association, that is from 2 to P and 2 to Q. So, 2P and 2Q. So, therefore, this is not a function. Okay. So, in general, what is the conclusion? A relation from a set A to the set B is said to be a function if every element of set A has one and only one image. Every element of the set A has one and only one image in the set B. So, here this has 2 images. So, therefore, this is not a function. Now, let us take another example. Let us come to a few examples based on this. Now, examine each of the following relation given below and state in each case give reason whether it is a function or not. So, we have to examine whether given condition is a function or not. Now, let us come to the first one. R is equal to, the relation is given by R is equal to 2 comma 1, 3 comma 1 and 4 comma 2. Now, what is the problem given here? let us come to the first one. Let us consider. Now, what is given? 2. The elements of the set A is 2, 3 and 4. This is A and B. So, this contains 1 and 2. Now, 2 to 1, this is 2 to 1, again 3 to 1, again 4 to 2. So, 2 to 1, 3 to 1 and all the elements of A are used one time. So, therefore, this is a function. So, f from A to B is a function. This is a function. F from A to B is a function. Okay. So, how to explain? Every element of the domain, this is called the domain. Every element of the domain are used only one time with the codomain. So, here the set of all first element of the relation is called the domain. Set of all second elements of the relation is called the codomain. So, here all the elements of the domain are used unique time with the codomain elements. So, therefore, this is a function. Okay. Now, let us come to the second one. R is equal to, what are the elements of R? Let us come to the second example. So, first elements are 2, 3 and 4. Second elements are 2, again 2 we have, 3 we have, 4. So, F, this is A and B. Check whether this is a function or not. So, what is the association given? The mapping is 2 to 2, 2 to 2 is given. Again 2 to 4 it is given, 2 to 4 is given. Again 3 to 3, 3 to 3 is given. Again 4 to 4 it is given. So, here this is not a function because the element 2 of the domain has used 2 times. So, the element 2 is used 2 times. That means, here this 2 comma 2 is 2 times. Therefore, this is not a function. F from A to B is not a function. So, F from A to B is not a function. This is not a function. Okay. That means the element 2 has 2 images, namely 2 and 4. There should not be 2 images like this. The element 2 of the set A has 2 images, 2 and 4. Therefore, this is not a function. 2 to 2 and 2 to 4 is not possible. So, therefore, this is not a function. Now, let us come to the second one. So, this is not a function. And the third one, what is the third one? Example number 3. Let us call it as A and B. Verify. A contains 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. B contains 2, 3, 4, 5, 6 and 7. So, map 1 to 2. This is the mapping 1 to 2. Again 2 to 3, 2 to 3. Again 3 to 4. 3 to 4, again 4 to 5, 4 to 5, again 5 to 6, 5 to 6 and 6 to 7. See here, all the elements of A and B are used. Further, there is 1 to 1 mapping. So, therefore, F from A to B is a function. F from A to B is a function. This is a function. Every element of the domain is related uniquely with the elements of codomain. So, therefore, F from A to B is a function. That's it. So, all the elements are uniquely related with the elements of the set B. Therefore, this is a function. That's it. Okay. So, these are example for functions and not a function. Okay. Hope you got an idea regarding the function. Okay. Now, let us take one more example. Which of the following relations or functions give reasons if it is a function, determine its domain and the range. Okay. Now, let us come to the first problem. 2 comma 1, 5 comma 1, 8 comma 1, 11 comma 1, 14 comma 1, 17 comma 1. Now, let us come to the first problem. Let us write down the elements. So, here A and B. So, A contains 2, 5, 8, 11, 14 and 17. B contains only one element. So, B contains only one element. Let us map 2 comma 1, 2 to 1, again 5 to 1, again 8 to 1, again 11 to 1, 14 to 1 and 17 to 1. All the elements are related to 1 only. What do you say from this, whether this is a function or not? So here no element of A is used 2 times. So clearly all the elements of the domain are uniquely related with the elements of the codomain. So therefore clearly this is a function. This is a function. So f from A to B is a function. Clearly this is a function. So all the elements of D, all the elements of the set A are uniquely associated with the elements of set B. So therefore this is a function. F from A to B is a function, right? That means clearly all the elements of the domain are uniquely associated with the elements of the codomain. So therefore this is a function. Now how to write the range and domain of the function? Write down the domain. Domain is nothing but set of all first elements. Domain of this function, domain of f is equal to set of all first elements of the function. Set of all first elements are 2, 2, 5, 8, 11, 14 and 17. These are called the domain. Set of all first elements 2, 5, 8, 11, 14 and 17. 2, 5, 8, 11, 14 and 17. This is called the domain. And what is the range? Set of all second elements. Range of f is nothing but set of all second elements. Only one element is there. That is 1 is the range. So the domain is 2, 5, 8, 11, 14 and 17 and the range is 1. That's it. Okay. Now let us come to the next example. What is the second example? Let me write here. Second one. This is A and B. Now what are the elements? 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 2, 4, 6, 8, 10, 12 and 14. Even numbers. What is B contains? B contains 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 and 7. Now what is the mapping given? Let us check once again. A contains 2, 4, 6, 8, 10, 12 and 6. 2, 4, 6, 8, 10, 12 and 14. B contains 1, 2, 3, 4, 5, 6, 7. Now the mapping 2 to 1, 2 to 1, again 4 to 2, 4 to 2, again 6 to 3, 8 to 4, 6 to 3, 8 to 4, then 10 to 5, then 12 to 6 and the last one is 14 to 7. See whether this is a function or not. Definitely all the elements of the domain are used uniquely with the codomain. So therefore f from A to B is definitely a function, is a function here. All the elements of A are used uniquely with the elements of set B. So therefore it is a function. And what is the domain here? Domain is nothing but set of all first elements of the function. That is set of first elements 2, 4, 6, 8, 10, 12 and 14. This is called the domain. And what is the range? Range is nothing but the set of all second elements of the function. Second elements are 1, 2, 3, 4, 5, 6 and 7. This is called the range. The set of all first elements comes under the domain and the second element is nothing but the range. Okay. Now this is a function. Now let us come to the third one. I will go to the third. What is the third one? So first element 1 and 2. So A contains 1 and 2 and B contains 3 and 5. Now what is the map given? Let me check once again. A 1, 2, B 3, 5. 1 to 3, 1 to 5. 1 to 3, 1 to 5. Again 2 to 5. See here, the element 1 of A has used 2 times as 2 associations, that is 3 and 5. So therefore f from A to B is not a function. F from A to B is not a function. This is not a function because 1 is associated with 3 and 1 is also associated with 5. So therefore this is not a function. That's it. 1 has used more than one time. The element 1 of the set A has used more than one time. Therefore this is not a function. So these are few examples for functions and how to verify whether they are functions or not, and to find the range as well as the domain of the function. Now let us come to the next problem, a simple problem. Since these are all the basics, so you are going to study the basics in this chapter. So these are all the basic concepts. Now a function f is defined by f of x is equal to 2x minus 5. Write down the values of f of 0, f of 7, f of minus 3. Now let us write what is given first. F of x is given. F of x is equal to 2x minus 3. Now what is to find first one? F of 0. Put x is equal to 0. Then you will get f of 0 is equal to 2 into 0 minus 5. That is 0 minus 5 is equal to minus 5. So therefore f of 0 is equal to minus 5. First answer, f of 0 is equal to minus 5. Now come to the second one. What is the second one? F of 7. Since f of x is given, f of x is equal to 2x minus 5. Now what is to find? F of 7. F of 7. So put x is equal to 7. Then this becomes f of 7 is equal to 2 into 7 minus 5. 7 to the 14 minus 5. 14 minus 5 is 9. So therefore function of 7 is equal to 9. F of 7 is equal to 9. Okay. Now the last one. What is f of minus 3? Now third one. Since f of x, what is f of x? 2x minus 5. Now to find f of minus 3, put x is equal to minus 3. Then this becomes f of minus 3 is equal to 2 into minus 3 minus 5. Minus 6 minus 5 is minus 11. So therefore f of minus 3 is equal to minus 11. So these are the values of f of 0. F of 0 is minus 5. F of 7 is equal to 9, and f of minus 3. These are the values we are going to get. This is how we are going to find the values of the given function whenever x is 0, 7 and minus 3. That's it. Hope you followed. These are very simple basic problems. Right. Hope you followed. These are few problems based on the functions and ordered pair and the Cartesian product. Okay. That's all regarding this session. Let us meet with the different concepts in the next class. Thank you. Thank you very much.